Hi everyone, today I'm gonna to present our project called MedExplain RAG, which is patient-friendly medical lab report explainer. This project is designed to help people understanding their medical lab results in a simple and clear way. Let's start with the problem. Many patients receive lab reports but they don't understand what the results actually mean. Medical terms like CBC, CFR, AST or T3 are difficult to understand. So people usually search on Google, but that often gives confusing or scary information. Because of this, patients feel anxious and unsure about their health. Our solution: to solve this problem, we built MedExplain RAG. This is an AI system that reads medical documents and answers questions in a simple language. First, we load medical PDF documents into the system. Then, when a patient asks a question, the system finds the most relevant information. Finally, the AI explains the answer in a clear and easy way. Also, it never gives a diagnosis and always suggests consulting a doctor. Now let's see how the system works step by step. First we load the PDF documents, then we split them into smaller chunks of text. After that we convert the text into numbers called vectors. These vectors are stored in a searchable database. When a user asks a question, it is also converted into a vector and system finds the closest matching information. Finally, the AI reads the information and generates a simple answer. We use 9 different model and medical lab test documents. This includes tests like blood test, hemoglobin, cholesterol, kidney function, and thyroid function. These documents help the system give accurate and reliable answers. We also define strict rules for how the AI should respond. First, it should only use the provided documents. Second, it should explain everything in a simple everyday language. Third, it should never diagnose the patient. And finally, it should always recommend seeing a doctor. This ensures the system is safe and trustworthy. We tested the three different AI models. PHI3 gives the most detailed and accurate answers. Gemma gives very simple and easy to read answers. TinyLlama is a fastest but gives shorter responses. Among these, PHI3 performed the best overall. Here is the example of the system output. We ask the question, what does low hemoglobin mean? Each model gives a slightly different answer, but all of them explain it clearly and suggest consulting a doctor. This shows how the system provides safe and understandable responses. We compared all three models based on different factors. PHI3 gave the most detailed and accurate answers. Gemma was the easiest to read. TinyLlama was the fastest. Overall, PHI3 performed the best in terms of quality and consistency.
Now let's dive into the coding part. Here is the final project structure. We have a data folder which contains the medical PDF documents used as the knowledge base, and ingest.py is used to build the FAISS vector database, and RAG pipeline contains the main RAG logic, and app.py it provides the Streamlit chatbot interface, and the JSON file it contains the evaluation questions. Evaluate.py runs the questions through 3 LLMs. Outputs.csv stores the raw model outputs, and FAISS index stores the saved vector database. Coming to the data folder, we have used multiple medical lab related PDFs including CBC, blood glucose, hemoglobin, lipid profile, metabolic panel, AST, T3 and GFR. These documents form the medical knowledge base for the RAG system. Ingest.py it is responsible for preparing the knowledge base. It loads all PDFs from the data folder, extracts text using PyPDF loader, splits the text into smaller chunks, converts those chunks into embeddings using all mini LM, and stores them in a FAISS vector index. And coming to the RAG pipeline, load vector store loads the saved FAISS index, retrieve context searches the vector database and retrieves the top relevant chunks, build prompt combines the retrieved context with the question and safety instructions, generate answer sends the final prompt to an LLM model and cleans the output. Main allows terminal based testing. App.py is the chatbot interface built with Streamlit. It loads the FAISS knowledge base once using session state, takes a question, retrieves relevant medical context, builds the prompt, and generates a patient friendly answer. We used 3 local open source models through Ollama, 5.3, Gemma 2B, and TinyLlama. 5.3 generally produced more detailed explanations. Gemma was concise and stable, and TinyLlama was lightweight but less consistent. Evaluate.py, this file automates model evaluation. It loads the questions, retrieves context for each question, builds the RAG prompt, runs the prompt through 3 models, and saves the results into outputs.csv. This helps us compare the same RAG context across different LLMs. Outputs.csv stores the raw results. It has columns like questions, model, and answer. This file is useful for checking how each model responded to each question. And comparisons output.csv, this is the final comparison output. It lets us compare all the 3 models side by side for each medical question. From this comparison, we observe that 5.3 usually gives more detailed answers. Gemma is short and stable. TinyLlama is faster but less structured. Our evaluation focused on performance, accuracy, and approach. Performance wise, smaller models like Gemma and TinyLlama were faster and more stable. 5.3 gave better explanations but required more memory. Accuracy wise, 5.3 generally aligned with better retrieved context. Gemma was usually correct but shorter. TinyLlama was sometimes less structured. We have built this MedExplain RAG using Streamlit, and here it is. So here we have an option to choose a model. A user can choose a model, like we have 3 options here: 5.3, Gemma 2B, and TinyLlama. And we have asked the model a question, and we have generated the answer like this. It can be seen here, and we have generated the same question for the remaining 2 models as well. So these are the 3 responses generated by 3 LLMs for the same question. So these are the responses generated by 3 LLMs for the same question. So to conclude, MedExplain RAG successfully demonstrates a medical domain RAG system using trusted lab test documents, FAISS retrieval, local open source LLMs, and Streamlit chatbot interface. The system shows how RAG can make medical explanations more grounded, patient friendly, and easier to understand. This concludes our presentation. Thank you.